I'm going to take this full-size diagram of the tree of life and we're going to produce a file for a plasma cut. I'm using Logitrace 2018 to digitize this diagram, and I've selected the circle command to digitize or to trace out the outer perimeter of the tree of life. The circle command is unique because all you do here, select circle command, select 3 points, check the diameter readout, correct it if necessary, and you're done. Now we're going to start tracing out the internal parts of the tree, starting on the right-hand side. It looks like a detailed or complicated looking diagram, but it's not. You draw out each section, and each section becomes a closed vector. The program closes that vector up, and you carry on with the next one. I always mention here that these videos are sped up 4 times because it would take forever to go through this process. The other point to note here is that these diagrams are easy to trace out and digitize because I get them printed full size. So the diagram is as large as the cut's going to be. Also, I forgot to mention here, I'm using tracing polylines, but you can use other selections. They all work. Tracing polylines just seems to be my favorite. I just continue tracing each section and letting the program close up that vector, and then I carry on with the next one, and again let the program close up that vector. It's important to treat each section as a closed vector because when you're finished this diagram and you check it, you don't want open vectors, especially with a plasma cut. It'll cause all kinds of problems trying to cut. I also started to mark off some of the sections I had traced because I was starting to make the odd mistake in tracing a section twice. And you can tell that because when you look at the monitor, the tracing will be a dark color. And again, that's going to cause problems when you do the final vector because you're going to have a vector on top of a vector. The plasma will not like that. Coming along here, we're starting to get most of the portions of the tree traced out. All the plasma cutter needs is the DXF file or a PLT file, and you handle the editing or the changes of the diagram with the plasma software. The diagram is complete. We've finished tracing and digitizing. I'm going to save my work. I'm going to load this file into Vectric Aspire 10.5, check the vector quality, and run it through the simulator. The simulator gives me a quick look just how this file is going to turn out. Once I'm happy with the file, we're going to load it into the Plasma software and start our cut. I've often said this, I find the plasma cutting amazing. Because I do a lot of woodwork, plasma is very new to me, and I find it smooth and fast. The only thing you have to watch with the plasma cuts, when that plasma cuts out that piece, and that piece doesn't fall through into the table, you got to make sure and grab it so the torch head doesn't hit that piece that's kind of half cocked and sticking up there. And in this case, the pieces are falling through nicely. Of all the machinery I use to demonstrate cutting these files that I've drawn up, the plasma is the fastest cut. Once the cut is finished, we'll remove the piece from the plasma table, flip it over, and we'll grind off some of those rough spots on the backside. The cut looks good. The cut steel plate is 34-inch diameter. Shown here, I've taken 8 pieces of 2x8 spruce, cut the angles, put them together with a biscuit joint, mocked up the steel plate, and now I'm showing the cut on the CNC machine. Right there you're seeing the rabbet cut where the steel plate will fit inside about 3/8 of an inch in and about 1/4 inch down. I'm running at about 19,000 RPM. I'm using a 1/4 inch carbide bit, and the feed rate's about 50 inches per minute. I use wood hold downs in case the machine hits one of my hold downs. Because the wood was so soft, I was able to get the speed up close to about 90 inches per minute. You'll notice here the dust collection is by hand. I take the dust collector off so you can see the cutter cutting the work. Quick note here, this whole frame is about 43-inch diameter. I programmed the machine here to cut 2 3/8 dowels as reference points in case I want to flip this piece over and work on the other side. Once we're done here, I'll then cut the inner circle out, and then I'll cut the outer circle out. You can see here when I'm cutting the outer circle, I had to use those hold downs on the rabbet to hold my work onto the table. The cut's finished. We got the rabbet cut, we got the outside cut. We're ready now to place the steel panel into the frame, put a finish coat on it, and hang it up. Because of the dark background, I put a white panel behind the steel plate, and it really shows up.